Hi, this is Todd with Land of Math. In this video, we're going to look at a real basic introduction to one-step equations. And by that, what I mean is we're not going to have any decimals or fractions or integers. We're just going to focus on the fundamental foundations that will kind of help you with equations further on down the line. In this video, we're going to have some different examples and some different rules that you can follow to kind of help your journey through the wonderful world of algebra and equations. Now, if you find the video helpful, give us a thumbs up. We always appreciate that. And if you'd like to follow along and subscribe, that'd be great too. Now, let's go right to the video. In this video, we're going to be looking at solving one-step equations. Now, when we're talking about equations, we're talking about things that equal. And when you look at an equation, it's going to have two things. It's going to have a variable, and it's going to have the equal sign. The equal sign means whatever is on one side of the equation is going to be equal to whatever is on the other side of the equation. You can kind of think of this like as a teeter-totter or a scale. The equal sign, I believe, is the fulcrum, if that's the right word. Whatever is on that left side has to be the same as on the right for it to be balanced. So these two sides have to be the same. Now, we have some different rules that we're going to look at here. First of all, both sides of the equation must be the same. So that's kind of rule one. We just kind of mentioned that. So if we're looking at a problem like, say, x plus 10 equals 25. The one side is 25. The x and the 10 together have to equal 25. So the following are some examples of when stuff on the left side equals stuff on the right. So for example, like this 6 plus 2 would equal 8. 9 minus 1 equals 8. You can have the 8 on the left side and have it 4 times 2. You can have even two problems that are totally different, like a 5 plus 4, and that would equal 11 minus 2, for example. Now, if we use our little scale here, if you will, both sides, whatever's on the right side equals whatever's on the left. Now, the next rule is whatever you do to one side of a problem, you have to do the same thing to the other side. So, for example, let's look at this 8 equals 8. And let's say we decide we're going to add 1 to the left side. Well, if we add 1 to the left side, it's 9 equals 8, and that's not accurate. They're not the same. So to make it so they're still equal or balanced, we're going to have to add 1 to both sides. So in this case, 9 would equal 9. Now, let's say we take the 9s and we multiply it by 2. We have to do it to both sides. If we do the same thing, we get the same answer, 18. Here we're going to divide by 3. As long as we do it to both sides, we'll get the same answer, and it's still equal, in this case, 6. All right, before we continue on, there's a couple other things we need to at least discuss. The first of these is something called variables, and we mentioned it earlier. Variable is basically the letter that represents something that we don't know in our equation. We use a letter for this. This is nothing different than back in elementary school where you have a blank. So blank plus 3 equals 5. Well, the unknown amount, instead of putting a blank, we'll just put the variable. So the following, you can see some different problems, like probably from elementary school where they used a blank. So for example, like blank minus 10 equals 25, or perhaps blank times 4 equals 24. If we want to make these equations, we just take out the line, the blank, and just replace it with a letter. And you can use any letter you want. In this case, I decided to use Y. Now, so all those right there are all variables. Now, when you're deciding which letter to use, you can use any letter you want. I kind of like to use letters that maybe represent something. So for example, if I was talking about, like I might use M if I was talking about money, maybe C for cost. If I was talking about percentages, I might use the letter P. I would use T maybe if I was talking about tacos. So I try to make it relevant. I try to avoid using S, and I try to avoid using Z, because when I get sloppy with my writing, the S looks like a 5 and the Z looks like a 2. All right, we need to take a couple seconds and talk about the multiplication symbols. You're used to using like the time symbol or maybe a dot to represent multiplication. But when we're dealing with equations and stuff, that's going to be a problem. For example, 4 times x is going to look like 4xx, which would be a problem. And then when we're multiplying with the dot, we're going to get it's going to look like a decimal if you get a little sloppy. So there's a couple of solutions. So number one, we're going to write as parentheses. So on these problems, like 4 times 3, we'll just put the 4 on the outside of the parenthesis, 3 on the inside. If the number is next to a parenthesis, it means we're multiplying. So in this next example, we'll put the 5 outside the parenthesis and the y goes on the inside. So 3 times f, the 3 would be on the outside, the f is on the inside. Now, the second solution is we're going to actually just write the letter right next to the number. So you can see this one right here, 4y is 4 times y, 8m is 8 times m, and 10t is 10 times t. This only works, though, with variables. If you try to do this with a regular number, it's a problem. So, for example, 2 times y, we could write with parentheses, or we can just write 2y. But if we do the same thing with 2 times 5, we're going to get 25, which is not going to work. All right, there's also a little difference when it comes to division. So when we're dividing, in the past we just used the division symbol. Like this case was 20 divided by 4 equals 5. Now, what we're going to do from now on is we're going to write all of our division problems as fractions. Fractions equal division problems. So, if you look at this one right here, 20 divided by 4 equals 5, we could write it as 20 on top, 4 on the bottom, and that would equal 5. So here's another example. 8 divided by 2, which would equal 9. We would put the 18 on top, 2 on the bottom, that would equal 9. 72 divided by 9, and that's going to equal 8. So if we set it up, it would be 72 on the top and 9 on the bottom. Now, because the fraction bar represents division, some people like to put little dots on top and the bottom of the bar to represent division. If that works for you, great. All right, so now to rule number 3. What we need to do is we're going to try to isolate the variable in these problems. Now, what that basically means is we want to get the variable alone by itself on one side of the equal sign. So, for example, like y equals 2 or 21, q equals 3, x equals 5. The variable can be on the other side too, so you can have like 17 equals y or 3 equals b. Rule number 4 is to isolate the variable. What we're going to have to do is we're going to have to do the inverse operation. And what does that mean? Inverse is kind of like thinking of it as the opposite or an action that reverses what we're doing. So in this example, x minus 2 equals 5. What we're trying to do is we're trying to get the x by itself. We want to get rid of the minus 2. So the way we can get rid of a minus 2 is do the reverse, go plus 2. On the other side of the equal sign, we have to do the same thing on both sides. We have to go plus 2 there. So on the right side of the equal sign, we have 7. Those two equal nothing. A negative 2 and a positive 2 equal nothing, so it's x equals 7. In this example here, x minus 7 equals 10. We're going to add 7, doing the opposite of minus 7. So on the right side, we're going to get 17. The minus 7 and plus 7 cancel each other out. We're left with x on the left side, x equals 17. In this example, we're adding 2. So what we're going to do to get rid of it is subtract 2. But we have to do it on both sides. And that's going to leave us with an x on the left side and a positive 6 on the right side. Okay, here's another example. Let's say we have 10y, and that equals 40. So because that's a multiplication problem, we're going to go ahead and divide by 10. We'll do that to both sides. And you'll end up getting y equals 4. So 40 divided by 10 is 4. We cancel out the 10s, get the y. On this problem, it's a division problem. X divided by 5 equals 20. We're going to multiply both sides by 5 because that's the opposite of dividing by 5. We end up getting 100. X equals 100. Now you might ask yourself, how can you multiply a fraction and only have the variable left? So what we're going to do here is we're multiplying this by 5. But we're going to write it as a fraction, 5 over 1. So we multiply these together. Now before we do that, we can actually cross simplify. And if we do that, each of these become 1. So when we multiply across, we get 1x on top and a 1 on the bottom. So 1x divided by 1, it's just going to equal x. So these next problems are just a couple examples of each type. So for this one right here, we have a minus 25. So we're going to add 25 to both sides. When we do that, we're going to end up with 55 on the right, x equals 55. In this case, we're subtracting 90. Do the opposite, do the inverse. Add 90. So we're going to end up with 92 on the right side, and on the left side will be x. So x is going to equal 92. This next problem, we're adding 71, so we'll do the inverse, minus 71. That leaves us 20 on the right, and only the x survives on the left. Here's another problem where we're adding. So we're going to do the inverse subtract, in this case 5. We end up with 59 on the right side, x on the left. Okay, on this next one, this is a multiplication problem. So we're, again, doing the inverse or the opposite, divide by 8. That leaves us with y equals 9. Our next problem where we're multiplying, we're going to do the inverse and divide, in this case 21. And so y is going to equal 3. And then on the next two, we have division problems. So we're going to do the opposite. In this case, we're multiplying, in this case, by 6. And when we do that, that's going to give us x on the left. And on the right side, we're going to have 18. In our last example, x divided by 20 equals 10. We're going to multiply both sides by 20. That's going to cancel out the 20s on the left and leave us x. And on the right side, we multiply 10 times 20. We're going to end up with 200. So x equals 200. The key thing in all these problems, all these examples, was to do the inverse or the reverse to find our answer. So here's a quick recap of our 4 key rules. Number 1, make sure both sides of the equal sign are the same. Make sure that whatever you do on one side, you do on the other. Always look to isolate the variable. And finally, use the inverse or the reverse operation to solve.